Hi children, good morning. In the previous video, we discussed factorial notation and step function. Okay, factorial notation means continuous product of first n natural numbers. Continuous product of first n natural numbers is nothing but factorial notation. And in addition to that, step function we discussed. Here, what is step function? Here, the value of x always less than its integral part. And for example, here 1.2 is given. Step of 1.2 is 1. Step of 1.5 also 1 only. Step of 1.9 also gives 1. Okay, don't confuse in these two things. That's why I explained that properties also in the previous video. In this video, we have to discuss the highest power containing n factorial. For example, the highest power of 2 contained in 10 factorial. Okay, in the expansion of 10 factorial, what is the highest power of 2 we will get. Okay, for understanding, I am writing this one. Afterwards, I give one form for finding highest power of any base contained n factorial. But the base should be prime. Here the expansion of 10 factorial, we have 10, 9, 8, 7, 6, 5, 4, 3, 2 and 1. Here we require highest power of 2 only. What are the generators of 2? Here all even numbers are generators of 2 only. Here 10 is 5 into 2. Here 8 is 4 into 2 means 2 cube also we can write. 7. Here 6, 2 into 3. 5 as it is. Next 4 into 2 square. Here 3 into 2 into 1. Here 2 power 1 plus 3 plus 1 plus 2 plus 1. In here 4, 5 plus 3, 8. Mean highest power of 2 contained in 10 factorial is 8. Highest power of 2 contained in 10 factorial. For example, 10 factorial equal to 10 into 9 into 8 into 6 into 5 into 4 into 3 into 2 into 1. Okay. Highest power of 2 means 2 power 8 results. For example, the highest power of 3 contained in 10 factorial is highest power of 3. Here, generators of 3, 9, 6, 3. Now, highest power of 3 means 2 plus, here 1 plus, here 1. Highest power of 3 contained in 10 factorial is 4. Highest power of 2 in 10 factorial is 8. Highest power of 3 is 4. For example, They gave highest power of P. P is prime. Contained in n factorial is step of n by b plus step of n by b square plus step of n by p cube and so on. Gives the required result. Okay, we need to check the first two results. The highest power of 2 contained in 10 factorial. Highest power of 2 contained in 10 factorial, we need to check. Now here 10 by 2 plus 10 by 2 square plus 10 by 2 cube plus 10 by 2 power 4. 10 by 2 means 5. 10 by 2 square. In here 10 by 4. 10 by 4 means 2.5. Plus 10 by 8 means 5 by 4 means 1.25. Plus 10 by 16. 10 by 16. In here 5 by 8 means 0.50 means 6 something 6 7 5 like that. Here 5 plus step of 2.5 is 2, step of 1.25 means 1, step of 0 point something means 0. Here 10 by 2 power 5 means 32. Okay, here in which all the real numbers will get the whole number as a 0 point something. That's why we need to omit those things. Now 5 plus 2 plus 1, 8. So highest power of 2 contained in 10 factorial is 8. Already we checked that one. Okay. Next. Second result. Highest power of 3. How much we got? 4. We need to check that one. Highest power of 3 contained in 10 factorial. Here, step of 10 by 3, step of 10 by 3 square, step of 10 by 3 cube, 3 over 4 something. Here 10 by 3 means 3.3 like that. 10 by 9 means 1.1 and so on. Plus here 0 point something. 10 by 27. Here 10 by 81 also 0 point something. So here step of 3.3 is 3, step of 1.1 is 1. So 3 plus 1, 4. The highest power of 3 contained in 10 factorial is 4. Okay. Highest power of 3 contained in 10 factorial. Highest power of 2 contained in 10 factorial. In this way we can find the required results. Okay, let us check another result. The highest power of 7 in 200 factorial. Highest power of 7 in 200 factorial. Okay, here n is 200, p is 7. Next 200 by 7. Next 200 by 7 cube. Whenever the exponent crosses this one, the numerator, at that situation you need to stop this process. Here 200 by 7 means here 2 sevens are 14, 60, 2 8s something 28 point. Here 200 by 49. For example, 200 by 50 means you get 4. So here 4 point something. Here 200 by 343. So 0 point something. So here 28 plus 4. Highest power of 7 contained in 200 factorial is 32. Highest power of 7 contained in 200 factorial is 72. Now next model. Here highest power of 15 contained in 120 factorial they ask. Highest power of 15 contained in 120 factorial. Here 15 is not the prime. If p is prime, we can use this one. Step of n by b plus step of n by b square plus step of n by b cube and so on. We can use this result for prime numbers only. Okay, from non-prime numbers are given. Okay, non-prime numbers are given mean first of all we need to arrange them into product of co-primes. Every composite number can be arranged as a product of primes. So by using that property we need to arrange in terms of primes. So here 15 equal to 3 into 5. So here we need to find the highest power of 3 contained in 120 factorial as well the highest power of 5 contained in 120 factorial. First of all, the highest power of 3 contained in 120 factorial. In 120 by 3 plus 120 by 3 square will 9 plus 120 by 3 cube will 27 plus 120 by 3 power 4 will 81 plus 120 by 243 3 power 5. Next here 120 by 3 will 40. 120 by 9 ones 30 will 3 times 27. So here 120 by 27. Here approximately 4 times. 4 27s are 108. 12 remainder. Mean 4 point something here. Here 120 by 81. 81 2 so 162. So more than that's why 1. Here 0. Because 240 is more than 120. Whenever you get proper fraction, at that situation you need to stop this process. Here 40 plus 13, 53, 57, 58. Okay, highest power of 3 contained in 125. 58. Next, highest power of 5 contained in 125. So 120 by 5. Here 120 by 25. Third 120 by 125. 5 cube. 120 by 5 is 24. 120 by 25. Being 425 is 100. 5 125. That's right. 4 times. Plus 0. Here we got 28. Here once we need to observe. Here you need to find the highest power of 15 contained in 120 factorial. For that, we require highest power of 3 as well as highest power of 5 contained in 120 factorial. Highest power of 3 is 58. Highest power of 5 is 28. The intersection of highest power of 5 and highest power of 3 is 28. That's why the highest power of 15 contained in 120 factorial is 28. Okay, the highest power of 15 contained in 120 factorial is 28. because here we want to get 15 power, we require 3 as well as 5. 15 square equal 3 square 5 square. 15 cube equal 3 cube 5 cube, like that. Here the power of 3 is more than power of 5. I mean here we got 3 power 58 into 5 power 28. For getting 15, only 28 enough. Okay, the generator of 15 mean 3 and 5 only. That's why here the required highest power of 15 contained in 1 to the factorial is 28. Okay, in this way you can find the results. Next, another model. Highest power of 8. Highest power of 8 contained in 100 factorial. Highest power of 8 contained in 100 factorial. Here 8 is not a prime, but 8 can be written as 2 cube. So here we need to find the highest power of 2 contained in 100 factorial first of all. Then 100 by 2 plus 100 by 4, 2 square will 4. Next, 100 by 8. Next, 100 by 16. Next, 100 by 32. Next, 100 by 64. Enough. The next power is 128. So, it is more than 100, that's why till 64 enough. 100 by 2 means 50. 100 by 4 means 25. 100 by 8 means 12. 12 and 5 means 12. Here 100 by 16. 16, 6 are 96. Next, 100 by 32. 32, these are 96. So 3 enough. 100 by 64 means 1. 6 plus 3 plus 1, 10. 10 plus 50. 60. 85. 97. The highest power of 2 contained in 100 factorial is 97. Okay, here highest power of 2, but we require highest power of 8. So here 2 power 97 you will get in 100 factorial. So 2 power 97 mean 2 cube whole power 32. In 3 32s are 96 into 2 power 1. So here 8 power 32 into 2 we can write. So the highest power of 8 is 30. The highest power of 8 contained in 100 factorial is 32. Okay, in this way we can find the highest power of any number, but we have formula for finding highest power of prime only. Other composite number other than prime are given mean, in this way you can find the highest powers. Okay, next. Small concept. The product of any r consecutive numbers is divisible by r factor. Already I said at the time of forms. The product of any three consecutive numbers is divisible by 3 factorial. Any two consecutive number divisible by 2 factorial. Okay, any four consecutive number divisible by 4 factorial. Any consecutive 5 factorial divisible by 5 consecutive number divisible by 5 factorial. Okay. Next, some examples. First one, show that the sum of any integer and its square, sum of any integer and its square is even. Sum of any integer and its square is even. Let n be the integer. Let n be the integer. Therefore, n plus n square, we need to prove it's an integer number. If you observe, n plus n square is nothing but n into n plus 1. N is a integer, n plus 1. N comma n plus 1 are two consecutive integers. Okay. R consecutive integer divisible by R factorial. Here, two consecutive integers are given. That's why is divisible by 2 factorial. Divisible by 2 factorial. 2 factorial is nothing but 2 only. So, n plus n square is even. N plus n square is even because it is divisible by 2. So the numbers which are divisible by 2 are called even numbers. That's why it is divisible by 2. And n plus n square is even. N plus n square is even. Next. Likewise, we can say that n into n square minus 1 is divisible by 6. N into n square minus 1 is divisible by 6. How can you say it is divisible by 6? Here, the factors of n square minus 1 are n plus 1 and n minus 1. If you arrange in order, n minus 1 into n plus 1. Here, n minus 1, n plus 1 are 3 consecutive integers. Is divisible by 3 factorial, that is 6. Okay, here n minus 1, n plus 1 are 3 consecutive integers. Now, product of any r consecutive numbers divisible by r factorial. Here, product of 3 consecutive numbers divisible by 3 factorial, that is nothing but 6. So it is divisible by 6. Next. Third one. Third one, if r is an integer, show that r into r square minus 1 into 3r plus 2 is divisible by 24. Now here r into r square minus 1 into 3r plus 2 is divisible by 24. We need to prove. So here r integer here. So r into r square minus 1 into 3r plus 2. Here r into r square minus 1 means r plus 1 into r minus 1. 3r plus 1. So 3r plus 2 equal 3 into r plus 1. R plus 1 we have, so r plus 2 minus here 3r plus 6, but we have only plus 2, so we need to subtract 4. Okay, 3 into r plus 2. Why you wrote r plus 2? Here we need to divide 24. 24 is nothing but 4 factorial. 4 into 3 into 2 into 1. So the number is divisible by 4 consecutive integers, then only it is divisible by 24. We can prove. So for getting 4 factor, here 3 consecutive numbers we have. Already we proved this one. R minus 1 and r plus 1 divisible by 3 factorial 6. So if it is divisible by another one, in r minus 1 into r and r plus 1, then you have r plus 2, then you can say that it is divisible by 24. That's why for getting r plus 2, I splitted 3r plus 2 in terms of r plus 2. 3 into r plus 2 minus 4. So here this r into r plus 1 into r minus 1 belongs to two terms here. One is 3 into r plus 2, another one minus 4. So 3 into r into r plus 1 into r minus 1 into r plus 2 minus again 4 into r into r plus 1 into r minus 1. Okay, I'll write in two parts here. First one, 3 into r minus 1 into r plus 1 into r plus 2. Next here, 4 into r minus 1 into r plus 1. If you observe, two parts we have. First part, 3 into r minus 1 into r plus 1 into r plus 2. Product of 4 consecutive integers. 4 consecutive integers is divisible by 4 factorial, that is 24. That is 24. So first part is divisible by 24. If the second part is also divisible by 24, then we can say that the given number is divisible by 24. Now let us come to second part. Here r minus 1 into r plus 1. Here product of r minus 1 into r plus 1 is divisible by 3 factorial, because these are 3 consecutive integers. Okay. Next, we have another number 4, means 4 into 3 factorial. So here 3 factorial means 6. 4 into 6 equal to 24. So now the second part is also divisible by 24. First part is divisible by 24, second part as well divisible by 24. That's why the given result r into r square minus 1 into 3r plus 2 is also divisible by 24. Most important result. Most important result. Here product of any r consecutive numbers divisible by 24. R factorial divisible by r factorial. here we need to prove if r is an integer, show that r into r square minus 1 into 3r plus 2 is divisible by 24. Now r into r square minus 1 means r plus 1 into r minus 1, r minus 1, r plus 1. Three consecutive integers we have. If you have r plus 2, another consecutive integer r minus 2 or r plus 2. But here, with respect to the given term, we will get only r plus 2 term. So 3 into r plus 2 minus 4. So here, according to the distributive property, the external part belongs to the both terms which are given in the bracket. Mean r into r plus 1 into r minus 1 belongs to 3 into r plus 2 as well 4. So here 3 into r plus 1 into r minus 1 into r plus 2. Here minus 4 into again r into r plus 1 into r minus 1. Here if you arrange in order r minus 1, r plus 1 and r plus 2, these are 4 consecutive integers. Divisible by 4 factorial. 4 factorial 24. Its multiples also divisible by 24 only. In 24 into 1, 24 into 2, 24 into 3, 24 into 4 like that. Okay, if it is divisible by 24 also, here multiple of 24 is going to be, it is also divisible by 24 only. Next, here second part, 4 into r minus 1 into r plus 1. Here r minus 1, r plus 1 are 3 consecutive integers. These are divisible by 3 factorial. Already we have the factor 4. So 4 into 3 factorial is 24. It is also divisible by 24. Here first part and second part as well divisible by 24. That's why the given number also divisible by 24 only. Next, the last one. If m comma n are positive integers, show that m plus n factorial is divisible by m factorial n factorial. When are positive integers, then we need to prove m plus n factorial is divisible by m factorial and n factorial. So here m plus n factorial by m factorial n factorial. Here m plus n factorial means product of m plus n consecutive integers. The product of 2 plus 3 means 5 consecutive integers mean 1 into 2 into 3 into 4 and 5 like that. Mean 1 into 2 into 2 plus 1 2 plus 3 no so 2 plus 2 2 plus 3 like that also can write. So here by m factorial by n factorial. Here product of first m consecutive number divisible by m factorial, m plus 1 into m plus 2 into and so on, m plus n by m factorial n factorial. Here m factorial get cancelled. Here m plus 1, m plus 2, m plus 3 and so on. Here m is a positive integer. So plus 1 plus 1 plus 1 plus 1 plus 1 mean these are consecutive integers. So here product of n consecutive integers by n factorial. Here product of n consecutive integers is also divisible by n factorial. So in here product of r consecutive integers they give. Here we have product of n consecutive integers. Here m plus 1, m plus 2 and so on mean m plus 1 plus 1, m plus 2 plus 2, m plus 3 plus 3. These are consecutive integers only. So here product of n consecutive integers divisible by n factorial. Mean here in the numerator you will get the multiple of n factorial. Here also we have n factorial. So multiple of n factorial is always divisible by n factorial only. That's why here you will get n integer. Here you will get n integer. So in your fraction after simplification you will get an integer mean denominator is completely divides the numerator. So it's a factor. So n plus n factorial is always divisible by n factorial n factorial. Okay, check with the help of examples. 2 factorial, 3 factorial is divisible by 2 plus 3 factorial is divisible by 2 factorial, 3 factorial. 3 factorial plus 3 factorial, 5 factorial is a factor of 3 plus 5 factorial. Like that also we can check. Okay, tomorrow we will start the 2 important things. One is Euler's function, Euler's quotient function. Another one congruences. Don't miss tomorrow's class. Tomorrow onwards most important. If you miss that one, you can't understand anything. Nothing. Okay. Have a nice day. Bye.